So here's the last video going over the last question. This is a pretty serious amount of material you have. If you're feeling overwhelmed, don't worry, that's okay. We're spending the whole next month on this same material. I gave it to you all today, but you don't have to understand it in depth all today. But anyway, the last problem was about an actual rocket flight. The same point, the same goal as what you have of designing a flight model for your rocket. So this brought you all the way up from a very basic introduction to quadratics to the point where you can use a quadratic model to model the flight path of a rocket, which was a lot of material. So the equation that was given, which is a real equation, if it's actually true, h of t was what we used, height at a given time, and it was negative 5t plus 5t squared plus 30t. And there's a little bit of a approximation here. The acceleration due to gravity on a rocket on Earth. There's a little bit of an approximation going on here. The acceleration due to gravity on Earth is actually 9.8 meters per second squared. And just to make it a little bit easier on you guys, I approximated that to 10, and then half of that gave us this negative 5. This is the force drawing the rocket to the ground. So really this should be 4.9 rather than 5. But that's okay. 5 is fine for us. So at time 0 was the first thing we were plugging in. When we plug in this graph at time 0, we get negative 5 times 0 squared plus 30 times 0. And 0 squared is 0. 0 times negative 5 is 0. So we've just got 0 plus 0, which equals 0, which makes sense. At time 0, the rocket's on the ground, at height 0. Okay. Next up, we plugged in 1. So at time 1, we've got negative 5 times 1 squared plus 30 times 1. So negative 5 plus 30, which equals 25. So after 1 second, this rocket has gone up to 25 feet. So next up we're plugging in 2. We've got 0 and 25. So negative 5 times 2 squared plus 30 times 2 is negative 5. 2 squared is 4. 30 times 2 is 60. So negative 20 plus 60, which equals 40. Alright, after 2 seconds, this rocket is 40 feet high. After 3 seconds, so negative 5 times 3 squared plus 30 times 3. 3 squared is 9, and 30 times 3 is 90. So we've got negative 45 plus 90, which equals 45. 45. And this happened to be 40, and this was 25, and that was 0. And then when we plugged in 7 and 8, we got negative values. Let's take a look at those. So 0, 45, 40, 25, 0. Let's check out 7. Negative 5 times 7 squared plus 30 times 7. So 7 squared is 49. And 30 times 7 is 210. And 5 times 49, well, let's see. 5 times 50 would be 250, so we're 5 short of that. So negative 245 plus 210, which is negative 35. Now, based on our model, the model that predicts height over time, the rocket would have dropped 35 feet into the ground. That doesn't make any sense. We know that what would actually happen is that the rocket runs into the ground, and that's it. So you should have realized that these were all good values, 45, 40, 25, 0. But these were bad values. They don't make sense in the context of the problem. So now I'm pulling up a graph, and your next task was, or your last task, really, the whole thing, was to graph these values. And you had a nice scale all set up, but I don't. I think it said something like 15, 20, 25, 30, 45, and 1, 2, 3, 4, 5, 6. So to plot the values in that table, you should have plotted 0, 0. You should have plotted 1, 25, 2, 40, 3, 45, 4, 40, 5, 25, and 6, 0. And you got a nice parabola like that, except for yours is even more accurate than mine. And you should have realized that at time 0 when the rocket's at the ground, that's the launch point. And here's where the rocket is at its highest. And here's where the rocket hit the ground. Alright, if you understood all that today, that's awesome. You're ready to go to do some rocket analysis. If you haven't understood some of that today, that's okay. Don't feel bad. That's what we're working on this whole month. Hope you had a good day. Have a good weekend. .8 meters per second squared.